So this is lesson 5 of factors and products, factoring polynomials that look like this. As you know, factoring is the process of writing a polynomial as a product, so as a multiplication of its factors. We can kind of think of it as the opposite of expanding. So let's first expand these 3 examples, and you can see what I'm talking about. X times x is x squared. X times 1 is 1x. 6 times x is a 6x. And 6 times 1 is 6. If we simplify that, we'll have x squared plus 7x plus 6. Next example, x times x again is x squared. X times 2 is a positive 2x. 10 times x is a positive 10x. And 10 times 2 is 20. So simplifying will get us to x squared plus 12x plus 20. Last example, x times x is x squared. X times 6 is a positive 6. Negative 2 times x is a negative 2x. Negative 2 times 6 is negative 12. So simplifying gets us to x squared plus 4x minus 12. So when you look at the expanded form versus when you are writing as a product of 2 factors, you can start to see some patterns. First of all, in each case, you have an x squared in front. Where do you get that from? Well, you get that from the x being the first variable in both sets of brackets, because x times x is x squared, right? X times x is x squared. X times x is x squared. So that's where the x comes from. There's an x in front of both brackets. Now, how about the middle number? Where does this 7 come from? Well, this 7 came from the 6 and the 1, because you went x times 1 is 1x, and 6 times x is 6x, for a total of 7x. So that middle number, 7, is just the 6 plus the 1. Just like this middle number 12 is the 10 plus the 2. Or the middle number 4 in this case is the negative 2 plus the 6. Okay, so what about the last term, the 6? Well, if the middle term was the sum of the 6 plus the 1, that last term is the product. So it's 6 times 1 is 6. Or 10 times 2 is 20. Or negative 2 times 6 is negative 12. So you could actually say in general that if you had a polynomial, a trinomial that looks like this, x squared plus bx plus c, where b is some middle number, c is the number on the end, that you can write it as a product of factors. So you can write it in factored form as x plus some number multiplied by x plus another number, as long as your middle term, the b, is the sum of those 2 numbers, and the last term, the c, is the product of those 2 numbers. Okay, so let's try this out. We're going to factor the polynomials that look like this using the steps on the left there. And the first step is you need to find 2 numbers that multiply to give you the last number, and also those same 2 numbers need to add to give you the middle one. So if we're looking at x squared plus 7x plus 10, we want to find 2 numbers that multiply to give us the last number, the 10, and those same 2 numbers need to add up to give us the middle, which is 7. Well, 5 times 2 is 10, and 5 plus 2 is 7. So those are our 2 numbers. Then all we do is we're going to take 2 sets of brackets, place an x in front of each of them, and use those 2 numbers. Just place them in the brackets. So x plus 5 and x plus 2. And what's great with factoring, again, by the way, this is your answer. That's the factored form. But what's great about factoring is that you can always check your answer. If you expand this, you should end up with your original expression. Let's try that. X times x is x squared. X times 2 is 2x. 5 times x is 5x. And 5 times 2 is 10, which simplifies into x squared plus 7x plus 10, which is the exact same as your original expression. So your factoring was correct. One quick note on this, the first step of any type of factoring is to factor out a greatest common factor first, if there is one. Let's take a look at another example. Here we have x squared minus 2x minus 24, and just because there's negative signs involved does not change our procedure. We're still looking for two numbers, then multiply to give us that last term, which is a negative 24, and those same two numbers need to add to give us our middle, which is negative 2. Now, if you're having trouble figuring out what those two numbers are, you can take the negative 24, which is the product number, and if you enter in your calculator negative 24 over x and create a table, you'll find a table of factors that you might be able to use. So let's take a look at what this would look like on a TI graphing calculator. So we'll go to our y equals, and we'll plug in the negative 24 divided by x and create a table, which is second function graph to create a table. And then you'll see two columns. And those are two columns of factors of negative 24. For instance, 1 times negative 24 is negative 24. 2 times negative 12 is negative 24. So these are all factors of negative 24, and all we need to do is find a combination that sums to negative 2. And I see one right here. 4 plus negative 6 is negative 2. So let's use those two numbers. So our two numbers are 4 and negative 6, which multiply to give you negative 20. And 4 plus a negative 6 sum to give you negative 2. Then we take our two sets of brackets, put an x in front of each, and then just use those two numbers. We had a positive 4 and a negative 6. And if you expanded that out, you would get your original result. So that is our answer. If you happen to write x minus 6 times x plus 4 instead, that is also correct. So let's keep going. And at any time, if you feel comfortable with this process, then you can just pause the video, do the problems yourself, and check in to see if we have the same answer. Okay, so x squared plus 2x minus 80. We're looking for two numbers that when you multiply them, give you negative 80. And those same two numbers, if you add them, will add up to a positive 2. Don't worry if it takes you a long time to find these numbers. With practice, it becomes a lot quicker. So negative 80 is negative 8 times 10. Do those numbers work? Negative 8 plus 10 is a positive 2, so yes, those can be our numbers, or will be our numbers. Take our two sets of brackets, place the x in front, and use those two numbers, x minus 8 and x plus 10 will be your answer. Okay, let's start with example 4 here, x squared minus 5x plus 6. Same process. We want two numbers that multiply to give the last one, which is 6. Those same two numbers, we want to add them to get us the middle number, which is negative 5. And when you're trying to figure out what these two numbers are, don't worry if you get them wrong. Just guess and check. Like if I thought that negative 6 and positive 1 would work, because negative 6 plus 1 is a negative 5, well, if I tried it here, negative 6 times 1 would be a negative 6, not a positive 6. So I know these numbers don't work. That's not a problem. Just try two more numbers. It's okay to get things wrong every now and then. So how about a -3 and a -2? -3 times -2 is a +6. -3 plus a -2 is a -5. So those sets of numbers work. When we choose our numbers, after we choose our numbers, we have two sets of brackets with the x in front, and we just place our numbers in those brackets. So we have x minus 3 multiplied by x minus 2, and that is our answer. Example 5. X squared plus 9x plus 12. We want two numbers that when you multiply them give you 12, and those same two numbers, when you add them, give you 9. If you have trouble finding two sets of numbers or a set of numbers that would work for this, then you're not wrong. If I listed all the factors of 12, for instance, 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Well, if you added those together, none of them will sum to 9. So none of the factors of 12 would sum to 9. That means this will not factor. So we can write a DNF, does not factor, because we can't come up with two numbers that will work. Well, let's hope x squared plus 18x plus 45 works. We're going to try two numbers that multiply to give us the 45. Those same two numbers we want to add to give us the 18. And this will factor because 3 times 15 equals 45, and 3 plus 15 equals 18. So we found our numbers. We'll take our brackets, place an x in front of each, and then use those two numbers there, +3 and +15. So x plus 3 multiplied by x plus 15 would get us x squared plus 18x plus 45. Okay, for the next one, it's written a little differently, and what I would do to start is write it in the form that we're used to, right? It's x squared, and then a number times x, and then a number by itself. So I would rewrite this as b squared minus 3b minus 28. Now that looks more familiar, so it's easier to tell that we are looking for two numbers that multiply to give us -28, and those same two numbers add to give us -3. -7 times 4 is -28, -7 plus 4 is -3. So we have our two sets of brackets, x in front of each of them, and our selected numbers fill out those brackets. X minus 7 times x plus 4. Okay, next question, next examples. -y squared minus 5y plus 24. So what I would do in this case, because again, we're working with trinomials that look like this, where you have a positive x squared. So what we'd want to do is factor out this negative sign here. So what we'll do is we'll factor out a -1. So we have a -1 there. We don't have to write the 1, so we can just write this as a negative sign. And then in brackets, we'll have y squared plus 5y minus 24. Basically, we just factored out that -1. And then from there, to factor out what's inside the brackets, that piece, we're still doing the same thing, finding two numbers that multiply to give us the last term, the -24. Those same two numbers are going to add to give us the middle term, which is 5. 3 times 8 is 24. So we can do a -3 times 8 would be -24, because -3 plus 8 equals 5. So then we can factor out what was in the brackets. We'll have our two sets of brackets, x and x. In there would be a -3 and a +8. Now that was the y squared plus 5y minus 24. But what did we do to it in the beginning? We had multiplied it by -1. So we have to do the same thing with our factored form. Our factored form must also be multiplied by a -1. So in case this looks a little too messy, our final answer is -1 times x minus 3 times x plus 8. Okay, looking at example 9 now. Again, we want to write this in the form that we're used to. So let's start by rearranging the numbers. You have a -x squared there, a -3x, and a positive 18. Now we don't like that negative in front of the x squared, so we'll factor it out. Factor out a -1, and then in brackets, you'll have -1 times x squared is -x squared. -1 times a positive 3x is a -3x. -1 times a -18 is a positive 18. And so then you can factor what's in those brackets there, the same way we've been doing. We want to find two numbers that multiply to give us the last number, -18. Those same two numbers are going to add to give us the middle number, the 3. So those two numbers, I can think of 6 and 3. So let's try -6, or positive 6, sorry, and -3, because a positive 6 and a -3 will add to give you positive 3. And 6 times -3 is -18. So again, what we did there is we found two numbers to factor out what was in our brackets. So we have x plus 6 in one set, x minus 3 in the other set. And we can't forget that the first thing we did was factor out a -1. So we should have a -1 outside all our brackets. So let's make that cleaner. -1 times x plus 6 times x minus 3 is our answer. Okay, last two sets of examples. Here we don't just have a -k, we have a -5k. Now remember, the first rule in any factoring is factor out the greatest common factor first. So if you can notice, all of these numbers are divisible by 5, so that would be your greatest common factor. And because we don't want a negative in front of the k squared, what we should do is factor out a -5 first. So we'll factor out -5, and then we'll have our brackets. -5 times k squared is -5k squared. -5 times a positive 4k is -20k. And -5 times a -12 is a positive 60. So then we can just factor what's in those brackets. Same method, two numbers that multiply to give you the last term, -12. Those same two numbers need to add to give you the middle term, 4. So that should be a positive 6 and a -2. Multiply to give you -12, and positive 6 plus -2 is positive 4. So we'll have our two sets of brackets with the x's in them. One has a positive 6, the other has the -2. Can't forget that our first step was factoring out that -5, so that -5 needs to multiply the x plus 6 and the x minus 2, and that would be our final answer. Last one, example 11, 6x squared y minus 24xy minus 144y. First step, factor out the greatest common factor. Each of these numbers, 6, 24, 144, is divisible by 6, and each of them also have a y in there. So your greatest common factor would be 6y. So let's factor that out. 6y, brackets, 6y times x squared will give you 6x squared y. 6y times a negative 4x would give you negative 24xy. And 6y times the negative 24 would give you 144y. So again, we're looking for two numbers that multiply to get negative 24, and those same two numbers need to add to give minus 4. And you know what? There are no pairs of numbers that will work in that case. So what's in the brackets there doesn't factor, so we just leave our final answer as 6y multiplied by x squared minus 4x minus 24.